Good morning all the students. So I'm going to show you the representation of the benzene ring. So first we have to understand what is the benzene. Benzene is the aromatic compound. It is the aromatic compound. And why it is aromatic compound? Because it follows the Haeckel's rule of aromaticity. It follows the Haeckel's rule of aromaticity. Now what is the Haeckel's rule of aromaticity? Any planar cyclic molecule which follows 4n plus 2 pi electron rule is said to be aromatic, right? It's said to be aromatic in a nature, right? So this is what is the aromatic compounds which follows the 4n plus 2 pi electron rule. Now how to represent this benzene, right? But before that we also need to understand who discovered the benzene. The benzene was discovered by the Kekulé. So Kekulé was the scientist who discovered the benzene. Actually there is a story behind the discovery of the benzene. Kekulé once was working in his lab, and during his working he saw in a dream, he slept in the lab and he saw in the dream that the snake is trying to touch the tail, and this led to the discovery of the cyclic compounds, right? So Kekulé is the father of benzene. Okay, now then representation. This is how we can represent, just by putting a simple circle in between. That shows that the pi bond character is everywhere in the structure, right? The pi bond character is everywhere in the structure, or you can also represent the structure in this way. Alternate single bond, double bond, or you can also represent by this way. Alternate single bond, double bond. So double bond can be here, 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 double bond can be here. This is nothing but called as the resonance. Last year you all have learned about the resonance, right? So resonance means what? One particular molecule can exist in a two or more forms. That is said to be a resonance. Now here we can see that there is a shifting of an electron is going on in the system, and the new structure is formed, right? So here that is why we write the canonical structure. This structure is said to be the canonical structure, right? Where the pi bond character is everywhere in the structure. That means the pi bond is also present here, pi bond is present here, pi bond is present here, pi bond is also present here, and pi bond is present here also. So both the possibilities are there in the case of a benzene, right? So in order to understand the haloarenes or the aromatic compounds, we have to first understand what is the benzene, because benzene is the basic compound of the particular aromatic compound. Okay, I hope that you might have understood this particular concept of benzene. Thank you.